Hello students, today I would like to start the subject Mathematical Foundations of Computer Science. It is very important to computer science students and it is also very useful. Actually, this is part of discrete mathematics. Discrete mathematics provides mathematical foundations for many computer science courses including data structures, algorithms, database theory, formal languages, computer security and operating systems, like that. Okay. Students find these courses much more difficult if they don't have appropriate mathematical foundations from discrete mathematics. Okay. That's why this subject is introduced for you. Okay. Let's start this. Mathematical foundations of computer science. Simply we call it as MFCS. This subject includes the topics mathematical logic, set theory, combinatorics, recurrence relations and graph theory. Okay. In this, the first one is mathematical logic. Mathematical logic. First, propositional calculus. Propositional calculus. Proposition or statement. Proposition is a declarative sentence that is either true or false but not both. Okay? Is a declarative sentence which is either true or false but not both. Okay. A proposition is a declarative sentence which is either true or false but not both. Okay. See the example. Two plus 3 is equal to 4. Second one, 5 into 4 is equal to 20. Third one, New Delhi is capital of India. Fourth one, Bangalore is the capital of Andhra Pradesh. Okay. These are all propositions. First one, 2 plus 3 equal to 4. This is wrong, but it is a declarative sentence. Okay. 5 into 4 equal to 20. It is true. New Delhi is the capital of India. This is true. Bangalore is the capital of Andhra Pradesh. It is false. Okay. If it is either false or true, a declarative sentence is called proposition. Hence, these four are propositions. First and fourth one are false, and second and third one are true. Okay. Next example. First one. What are we doing? Second one. Read this book carefully. Third one. X plus 2 equal to 6. Fourth one. X plus y equal to z. See this. These are not propositions. What are you doing? These two are not declarative sentences. Okay. and we don't know the values of xy, and hence we cannot say whether they are true or false. Okay, and hence these are not propositions. Okay, understand? Proposition means that is a declarative sentence which is either true or false. Okay, truth value. If a proposition is true, then its truth value is denoted by T. If a proposition is true, then its truth value is T. Okay? If a proposition is false, then its truth value is F. Okay? Some authors use the notation 1 for T and 0 for F. Okay? Some authors use the notation like this. Okay? Next, compound proposition. Compound proposition or compound statement. A proposition obtained by combining two or more statements is called a compound proposition. Okay? Obtained by combining two or more statements. A proposition obtained by combining two or more statements is called a compound proposition. Okay? If it is not compound proposition, then it is called primitive proposition. Primitive proposition. That means a simple proposition. You cannot write this as a combination of two or more propositions. Okay? Primitive proposition means that is not compound. That means a simple proposition. Okay? See the example for compound proposition. 2 plus 3 equal to 5 and 5 into 7 is equal to 40. Second, Prashant is a clever boy, or he studies every night. These two are compound propositions. See the first one. This is the combination of two propositions. 2 plus 3 equal to 5 is one proposition. 5 into 7 equal to 40 is another proposition. Okay. Second one. Prashant is a clever boy, or he studies every night. This is also combination of two statements. Okay. Prashant is a clever boy, one proposition. He studies every night is another proposition. Okay. These two are compound propositions. Okay. Next. Truth table. What is the truth table? Okay. Truth table displays the relationship between the truth values of the propositions. Okay. And you know that if your proposition P is true, then the truth value is T. And if your proposition Q is false, then its truth value is F. Okay. The truth table displays the relationship between truth values of the propositions. Okay. Next definition. Negation. Negation of a proposition. Let P be a proposition. Let P be a proposition. Then it is not the case that P is also another proposition. That is called negation of the proposition P. Is called negation. The statement is called negation of the statement P and is denoted by negation P. Okay, read as not P. See the example for negation. Today is Friday. What is the negation of this statement? Negation of this statement. It is not the case that today is Friday. This is negation of the given statement. Or simply we can write, or simply today is not Friday. You can write the negation like this simply. Okay. Next definition, conjunction. Conjunction. Conjunction means a statement obtained by combining two statements by the word and. Okay. A statement obtained by combining two statements by the word and. Okay. If P and Q are two propositions, if P and Q are two propositions, then their conjunction is P and Q. Their conjunction is P and Q. Read as P and Q. Okay. This is conjunction of P and Q. And this conjunction is true. P and Q is true when both P and Q are true. Conjunction is true when both the statements are true. Okay? In all other cases, the conjunction is false. The truth table of conjunction. Truth table for conjunction. P, Q. P and Q. P and Q means conjunction of P and Q. Okay. So write the possible truth values of PQ, TT, TF, FT, FF. Okay. These are the possible truth values of P and Q. Okay. And you know that conjunction is true only when both the statements are true. In all other cases that is false. TT, that means both are true, then the conjunction is true. TF, F, FT, F, FF, F. Okay. This is the truth table for conjunction. Okay. See an example for conjunction. Find the conjunction of two statements, of two propositions. P and Q. Where P is today is Friday, and Q is the proposition. It is raining today. P is the proposition, today is Friday, and Q is the proposition, it is raining today. Now we have to find the conjunction of these two statements. The conjunction of P and Q is the statement P and Q, denoted by P and Q, is the proposition. What is that? Today is Friday and it is raining today. Today is Friday and it is raining today. This statement is true on rainy Fridays. Since you know that conjunction is true and both the statements are true. Okay, that means this statement is true only on rainy Fridays. Next, disjunction. Disjunction. It is a compound statement. It is a compound statement obtained by combining two or more propositions by the word or. Okay, so by using the word or, combine two or more propositions, then we get a new proposition that is called disjunction. Okay, if P and Q are two propositions, then their disjunction is denoted by P or Q. And the disjunction P or Q is false when both P and Q are false. Disjunction is false only when both the statements are false. See the truth table for disjunction. Truth table for disjunction is P or Q. P or Q. Write the possible truth values of PQ, TT, TF, FT, FF. Okay. Now, you know the disjunction is false only when both the statements are false. Okay, and hence TT, P or Q is T, TF, T, FT, T, FF. Since both are false, disjunction is false. Okay, this is the truth table for disjunction. See an example. China is in Europe. Or 4 plus 5 equal to 9. Second, China is in Europe. Or 4 plus 6 is equal to 11. See these two statements. China is in Europe. It is false. 4 plus 5 equal to 9. That means one of these statements is true and hence the disjunction is true. See the second one. China is 11. These two are false and hence its truth value is also false. Okay. First statement is first one. Is true. First statement is true. Since one of these two statements is true. The second one. Second statement is false. Since both the statements are false and hence the disjunction is false. Next, exclusive or. Exclusive or. If P and Q are two propositions, then their exclusive OR of P and Q denoted by P exclusive OR Q, read as, okay, is this statement is true when exactly one of P and Q is true. Exactly one of P and Q is true. Okay, this is exclusive OR of P comma Q. Truth table for exclusive OR. Truth table of exclusive OR. P Q P exclusive OR Q. Okay. Write the possible truth values of PQ, TT, TF, FT, FF. And you know that exclusive OR is true when exactly one of the statements is true. Okay? TT. Then also it is false since exactly one statement is true. TF, T, FT, T. Since exactly one statement is true. FF, F. Okay. This is the truth table of exclusive OR. Next, implication. This is also known as conditional statement or implication. Okay. If P and Q are two propositions, P and Q are two propositions, then the implication of P comma Q is P implies Q. Implication of P and Q denoted by P implies Q. The implication is false. P implies Q is false when P is true and Q is false, and is true in all other cases, and is true otherwise. Okay, that means implication is false when the first statement is true, second statement is false, and that is true in all other cases. See the truth table for implication. Truth table. P, Q, P implies Q. So write the possible truth values of P, Q, TT, TF, FT, FF. Okay. And you know that implication is false when the first statement is true and the second statement is false. Okay. Now TT implies T, TF, F, FT, T, FF, T. Understand? Implication is false only when P is true and Q is false. Okay. That means a true statement cannot give the false statement. Okay. Next, converse, contrapositive, and inverse. Converse, contrapositive, and inverse. There are some related implications which can be formed from the implication P implies Q. Okay? P implies Q is the given implication, then its converse is Q implies P. Its contrapositive is negation Q implies negation P. Inverse. That is, negation P implies negation Q. These are converse, contrapositive, inverse of the implication P implies Q. Next, biconditional or by implication. By implication or biconditional. Okay, let P comma Q be propositions. Let P comma Q be propositions. Then the biconditional denoted by P by implies Q. This is proposition. That means is a proposition which is true. Which is true when both P and Q have the same truth values. Have the same truth values. This by implication is true only when both P and Q have the same truth values. That means both are true or both are false. Then only the biconditional is true. Okay? One is false otherwise. One is false otherwise. See the truth table for biconditional. Truth table. P, Q, P by implies Q. So you know that biconditional is true only when both the statements are having the same truth values. Okay? Let's write the possible truth values of P and Q. TT, TF, FT, FF. Okay? P by implies Q. Only when the two statements are having the same truth values, biconditional is true. TT, same truth values, and hence it is T. TF, F, FT, FF, same truth values, and hence it is true. Okay? This is truth table of biconditional. Okay, students, thank you so much for watching. See you in the next video.